Hi, in this video we're going to solve one more application of quadratic formula or quadratic equations. And here's the problem. It reads, two boats leave the harbor at a right angle to each other after leaving the same dock at the same time. 1 hour later, the boats are 17 miles apart. If one boat travels 7 miles an hour faster than the other boat, find the rate of each boat. Okay, let's try this. So notice that we might have some dock here. This could be the dock. And the boats are traveling at a right angle to each other. So maybe one boat travels east. That would mean the other boat either traveled south or they traveled north or something like that. But what the idea is that you get a right angle off of the dock. So for the sake of curiosity, or just for the sake of drawing some boats, let's send our boats off. We'll send one boat off to the east and one boat down to the south. Now, it says in the problem that, let's see, so we've taken care of our right angle. It says 1 hour later, the boats are 17 miles apart. Well, when you think about how far apart the boats are, what you're really doing is you're looking here. This is the 17 miles. That's how far they are apart. So the question then is, well, what is the distance of this boat? And what about the distance for this boat? Okay, so now what we need to do is let's go back and recall. Remember, in an earlier video, we talked about the distance being the rate at which you're traveling times the amount of time for which you travel. So in this problem, we have one boat at some speed and another boat at 7 miles faster than that. So what we could do is, let's say the first boat has a speed of x. So for example, if the first boat was traveling 10 miles an hour, the other boat would be traveling 17 miles an hour. And you get that by saying, oh, that's 10 plus 7. Well, what we did is we took the second boat's speed, or the first boat, so oops, I want to go. So second boat has a speed of whatever the first boat is, plus 7 miles an hour more than that. So then the other piece that we have here is the time. Notice the time. The time was the opening line in the sentence. It was 1 hour later. So now we can actually write these distances. The distance of our faster boat is the rate at which it's traveling, x plus 1, times the amount of time. And the distance of our slower boat is the rate at which it's traveling, which is x, times the amount of time, which is 1. And so now we have the distances for the boat. One of them is x plus 1, and the other one is just x. But now we've also got another piece. It said when we drew our picture, notice that we drew it on purpose at a right angle. So this is just a right triangle, and we can solve this by utilizing the Pythagorean theorem. So I'm going to scroll down a little bit, and if we write our relationship, remember the Pythagorean theorem says that the sum of the square of the sides is equal to the square of the hypotenuse. So one of my sides is x, and I have to square it. The other side is x plus 1, and we need to square that as well. And then, oh, I'm sorry, not x plus 1, x plus 7. Let me get that right. Let me write it nicely. X plus 7. Okay, there we go. Equals, and then the distance is 17, and we need to square that as well. Now let's clean up what we have. I'm going to write the first term as x squared plus, and then remember you need to distribute the x plus 7. And this is also a perfect square, so if you're not quite sure about this, you should pause the video and try. But this gives me an x squared plus 14x plus 49. And 17 squared, that's 289. So now, let's clean up what we have. This is 2x squared plus 14x plus 49 equals 289. Well, I am going to hope that this one solves by factoring. So if I want to try that approach, I would subtract the 289 from both sides and set the equation to 0. So now I have 2x squared plus 14x, and then 49 minus 289, that's minus 240 equals 0. Okay, well, this is all right. You could work with this if you wanted, but notice there's a common factor of 2. So if I think of this as x squared plus 7x minus 120 has to equal 0. And then, just to make things even cleaner, notice I could multiply both sides of this equation by 1/2. And the result is that 2 that I factored doesn't affect the problem at all. It just cancels. Now I have x squared plus 7x minus 120 equals, and then 0 times 1/2, that's 0. And now let's factor this. So let's see, if I play the game, I have 1 times negative 120. That's 120, negative 120. And I need a 7 in the bottom. Now this one to me is not so obvious. So when I look at it, I notice that if I don't worry about the sign, I notice that 120 is the same as 10 times a 12. And if I factor these, I can factor these into a 5 times 2. And the 12 is a 2 times 6, but 6 is 2 times 3. And then I'm going to rearrange my numbers, and just for the heck of it, let's put all the 2's together and see what happens. So what if I think of this as 2 times 2 times 2 times 5 times 3? Oh, but wait a minute. This is 8. The 2's give me an 8. And then 5 times 3, that's 15, and there's the answer. So let's use this, write our answers as plus 15 minus 8. Now we can rewrite our equation as x squared plus 15x minus 8x minus 120 equals 0. And let's find common factors. In the first group I have an x, so that's an x plus 15. In the next group I have a negative 8, so I have an x. That's going to change the sign on the 120. And notice if I factor, and if we look down at the bottom here, if we factor an 8 out of a 120, we're left with the 15. So plus 15 equals 0. My greatest common factor is now x plus 15 times x minus 8. And then what we do is we set each factor to 0. So x plus 15 is 0, or x minus 8 is 0. So notice my answers are x equals minus 15 or x equals 8. Now, here's the interesting part about this, and that is we know we can't, doesn't make sense to have negative speed. So let's make this negative speed does not make sense. So the answer has to be x equals 8. Now, don't stop there, because remember the problem was about 2 boats, not just one. So if this is our x is 8, let's go back up to the problem and see if we can figure out what the second boat's speed is. So, here it is. So let's take a look here. If we highlighted this, it says right here, second boat has a speed x plus 7, and that's what we needed. So in other words, if we have x here is 8, then we know that x plus, that 8 plus 7 is 15. So the second boat is traveling at a rate of 15 miles per hour. And that is our final application of problem solving using quadratic equations. Thanks for watching.